Hello there, my name's Adam Killen. I'm part of Killen Bros contracting. So we're out with John here today. We separated from him in the past there, and we're going to find out that we save him money. We're with Jack from BH Estates. We're going to talk about the results and the economics from the slurry separation that we done earlier this year. So earlier this year when we came out to John's farm to separate it, what really meant we were putting the liquid to one side and to another tank, and then we're putting the solids out to the trailer and then into our silo. Some we're storing it in two separate places. The liquid then John used on a later date for his grazing ground and his silage ground, and then the solids then he used, he put them wherever was required, which field or anything for his whole crop maize or wherever he needed, if he needed them or what he wanted to do with them in his own time.
As a farmer, from my point of view, what I'm looking for is actually what is happening when we separate slurry. Where are the nutrients going? Thirdly, can I export the extra nutrients that I have off farm? And fourthly, is it going to save me money? Otherwise, is it going to save me the amount of chemical fertilizer that I need to purchase on the farm over the period of the year?
Right, so Adam, could you explain to me actually what slurry separation is?
So we come onto your farm, we suck on the raw slurry from the tank, we then split it to your fibre, your solids goes out a belt, and then your liquid returns into a separate, through the screw press, which separates the liquid into another tank.
Okay, and Jack, you've been separating as well?
Yeah, so I run a project called Farm to Export, and it's a DERA-funded research and development project, and we have a big mobile separator as well. And in that project, we're doing a lot of research on what the nutrient contents are of those solid and liquid fraction, and also whether or not the solid fraction is able to be used in biogas production.
What nutrients are in the different materials then?
So broadly, the solid fraction will have a higher amount of phosphorus, a higher amount of phosphate per tonne. The liquid fraction will have higher ammoniacal nitrogen per 1,000 gallons, slightly by about 3 to 5%. It will be it'll be wet. The liquid fraction will be wetter, more diluted, and so there's a range of benefits that those can that using those using separation can give you with those two different fractions.
And you say ammoniacal, you mean as an available nitrogen?
Yeah, ammoniacal nitrogen is available nitrogen.
So I should be able to save fertilizer by separating slurry?
I think that on nitrogen use efficiency, yes, you can save fertilizer if you replace raw slurry with liquid slurry separate, if you are using separators correctly.
And that also gives me an option then to export extra nutrients off the farm that I perhaps maybe will need to do.
Yes, and our project is about moving phosphorus from farms where those nutrients need to be moved. And so one of the challenges with that is turning cattle slurry into something that is worth transporting. Now, if you take your solid fraction, we think that it is close to worth transporting that solid fraction to use for biogas production. Okay. So what that does is it gives the farmer an option that if they want to export the slurry, that there is somewhere viable for that to go.
And when I had Adam here before separating slurry, we weren't overly concerned about the dry matter of the solid material. But if I was going to an AD plant, is that more critical?
Yes. So if your solids are less than 25% dry matter, and look, some use that as a broad brush, but if your solids are less than 25% dry matter, the value to the AD plant is going to be much reduced.
Right. Okay.
But it is easily accomplished. It just is a matter of tightening up the backing plate and really draining, screwing the materials.
Yeah. So and different. So Adam is using a Borger separator. We have a separator manufactured by a company called Slutsmid, which uses fan, and both of those are capable of producing solids more than 25% dry matter. Yeah. Technology does matter. The reason why the dry matter matters is because if Adam is to use solids in his AD plant, he doesn't want to have to double the feedstock that his AD plant takes.
Right.
So the drier the solids, the more gas they will produce.
If there was an AD plant that could take my solids, what nutrients would I actually be exporting?
So, great question. And this is done in kilos per tonne because that's where your regulatory returns are done. So, and this is on our data. Our data shows an average of 5 0.25 kilos of organic nitrogen per tonne, and it shows 2.1 kilos of phosphate per tonne. And that's over a very wide number of samples. There's like 70 different lab samples.
So it's not one farm.
No, and it does vary, but those are your averages, and it's sensible for the regulations to do
And variations as in being heavy fed or high yielding here to an average here? No.
I haven't sort of run through this all, but I suspect that the difference is less to do with feed and more to do with slurry management on farm. So for example, if you protect your tanks from being diluted with rainwater, if 50% of your tank is rainwater, then you're going to have 50% less phosphorus or nitrogen per cube or per 1,000 gallons. That is the biggest variation we see on farm, and we do see a very wide variation in the dry matter in slurry. So from 4 up to 14 is what we have in our database, and like 20% of the slurry that we have in our database is over 9% dry matter. So, and that makes it very, very hard for low emission slurry spreading. And low emission slurry spreading is where you get more value out of the nutrients, out of the nitrogen in your organic material. And that's where you can get to your fertilizer bill reduction. What we have is we have a database, a nutrient database, and that's been about 8 years in the running to build it. If you've got your 3 fractions, you've got unseparated slurry, you've got liquid separated slurry, and you've got solid separated slurry. And like broadly, the ammoniacal nitrogen increases a little bit. It won't show in units, but ammoniacal nitrogen is about 16 to 17, and in the unseparated, about 17 to 18 in your liquid fraction. Your phosphorus on average reduces a couple of units in your liquid fraction compared to your unseparated material, so you're spreading less P, and your K is about the same. But one of the most important points in this is that the dry matter in your liquid reduces, and what that gives you is the ability to use nitrogen more efficiently. You lose less nitrogen. And then in your solid fraction, we have about 12 units of available nitrogen compared to 17 in your liquid. So we're not taking as much available nitrogen off the farm if that's going to be exported, and we are trying to get that running as an AD feedstock model. And the phosphate is at 20 units, so it's a higher in phosphate material. There's a lot of work that's gone into that database. The values are kind of subject to change because it's an ongoing research project, but we've got a lot of data there, and it's up on the screen to see.
So Jack, if I was to separate 300,000 gallons of slurry,
All your slurry.
all my own slurry,
Yeah.
and use that then, for instance, on silage ground, how many units of nitrogen, in your estimation, would I be saving?
So, and this is purely on the maths to do with nitrogen when you're spreading it.
Yeah.
But if you separated 300,000 gallons, you save about 500 units of nitrogen, using the model that we've kind of just discussed. Enabling a trailing shoe and the quickest soil perforation.
That's quite a...
It's quite a lot of nitrogen.
500 units of nitrogen is quite a lot of nitrogen.
Yeah.
So it is for 300,000 gallons of slurry. So from my point of view, what can that save me in fertilizer terms? How much nitrogen will I benefit from separating the slurry?
So it's a great question, and what we're really talking about there is how much more efficient is the use of nitrogen in my organic matter if I use separated stuff rather than unseparated stuff. And what we do there is we take the baseline, which is 3,000 gallons of slurry per acre, and you've given us an example. You've given us 60 acres to work through an organic nutrient management plan, and we've come up with 3 different scenarios. And the first scenario is the baseline, where you need And shown in the screen, 3,000 gallons per acre of unseparated slurry over 60 acres. And the result is you're going to need 8 tons of mineral fertilizer. So scenario 2 is you're swapping all your slurry for your liquid separate. And you're also going to swap to a trailing shoe. And again, you're going to do a 3,000 per gallon, 3,000 gallons per acre. And what you then get is your nitrogen use efficiency increases so that you only need 3 tons of mineral fertilizer to balance that.
Okay.
And the reason for that is that you lose less nitrogen when you are using a more diluted slurry. So even if you didn't swap to a trailing shoe, you'd still reduce your nitrogen use to about 5 tons.
All right.
Okay. You'd still only need 5 tons of mineral fertilizer. But also because you have diluted it to below 6% dry matter, it's much more likely to be able to go through a shoe if that's something you wanted to do. And what that is, it's entirely driving nitrogen use efficiency. Now, the other thing you can do there is you can take a balanced approach and you can look at what we call an integrated nutrient management plan, where you're trying to reduce the amount of P that you've got on your holding, because P is going to come in feed, and P in feed is quite high. Is quite high, yeah. And you also want to reduce your mineral fertilizer a little bit. So a balanced plan which takes into account reducing P, but also making savings in mineral fertilizer. Same amount of slurry spread, so across the 60 acres, still spreading 180,000 gallons. You know, you started with 180,000 gallons. Is you're reducing your mineral fertilizer purchase by 25% across that 60 acres. So you've 6 tons to 8, but you've got 50% less P being spread in your organics on that 60 acres if you use, and what that means is you're taking your soil testing data from the Soil Nutrient Health Scheme or your own testing data. You're taking your slurry results, and you are applying what each crop needs and trying to get a balanced model that reduces mineral fertilizer, that reduces your ammonia loss, and then also increases the nitrogen use efficiency and also keeps your P balance on farm in check. So for the farmer, there's a real economic, tangible, circular benefit there. And for government, there's also a benefit in that, you're reducing a P. Government wants to reduce P oversupply where that is the case. They want to reduce ammonia a loss. This is what does that. And they want renewable energy, and they want to reduce methane. And by moving the solids away, you can do that. Yeah. So that's kind of where we got to with that, is that you can save on your fertilizer, and there are other savings there as well. So
well, that's it. Yeah, so I can save my fertilizer. I'm obviously going to save if I was using Atom and the pipeline system, I would be saving time for the point of view they can pump an awful lot faster when he's not pumping thick slurry. So I would probably save money there as well. And I suppose where would the third thing be really efficiency?
So I think that the third thing is you're creating space in your tanks. And what you're doing when you're creating space in your tanks is the nutrients in slurry is valuable, but it's only valuable if it is used at the right time.
Yeah.
When would you prefer to spread your slurry?
Well, whenever the weather conditions are right.
Yeah.
Rather than sitting waiting until the 1st of February and then thinking we have to go. We found this year it definitely created room in the tank. It definitely put us under less pressure. And I actually can see the separated slurry where it did go out on silage ground, there was a noticeable difference.
And what was the difference?
Well, I thought there was much earlier growth.
Yep.
I know when I went out then with chemical fertilizer, I didn't go out with as much. I have cut back on what I used. And I also noticed when you went out onto the ground, the next day there was no visible evidence that there had been slurry put onto the ground. So you're back into the situation, which I haven't had a problem with, is contaminating the silage. But you can see there would be a problem putting on thicker slurry, especially with trailing shoes, dribble bars, stuff like that there. They can't work with the heavier material. It doesn't get down into the ground. So that eliminates that completely. But that's one good benefit. But I have definitely noticed the difference in the growth from the separated slurry.
And I think that's where you're touching on a really good area of how it's complicated to quantify these benefits, because they are in nitrogen use efficiency, which is a financial benefit in fertilizer. They are in keeping your on-farm nutrient balances in check, which is your organic nitrogen loading, your phosphorus balance. They are less money spent to Adam on spreading, because he's spreading it, instead of 20,000, 25,000 gallons an hour, he's spreading it 35,000 gallons an hour with the liquid. It's less contamination in your silage, because the fiber in your unseparated stuff can contaminate the leaf of the grass. And it's the timed placement of those nutrients. So when the soil temperature is higher and the nutrients are coming,
you get more benefit from it.
And that's what we're seeing in our kind of feedback from farms that we've been separating on as well.
Well, as we have separated twice this year earlier on, I'm now planning to bring Adam back in with the separator before first cut, or as close to first cut as I can. So we'll be putting out separated slurry again after first cut, because the benefit was clear. Absolutely, we'll definitely be doing that. So no, I think it is definitely good potential.
You've enjoyed the experience?
I've enjoyed the experience, yes.
Great.